Hi viewers, I am Dr. N. Swami, Professor, Department of Mathematics, KS Rangasam College of Technology, Tirunelveli. In this video, we are going to discuss moment genetic function mean and variance of binomial distribution. Binomial distribution is the discrete probability distribution that gives only two possible results in your experiment, either success or failure. For example, if you toss a coin, there would be only two possible outcomes, heads or tails. And yet any test is taken, then there would be only two results, pass or fail. This distribution is also called a binomial probability distribution. The probability of x success in n trials is given by p of x is equal to ncx p power x q to the power n minus x. So here, probability of success plus probability of failure, that is equal to 1. That is p plus q is equal to 1 and q is equal to 1 minus p. Then this q plus p whole to the power n, this binomial expansion can be written as q power n plus nc1 q to the power n minus 1 p power 1 plus nc2 q to the power n minus 2 into p square plus and so on plus ncx q to the power n minus x into p power x. So now we are going to find moment genetic function mean and variance of binomial distribution. So this moment genetic function MGF of a random variable x whose probability function p of x is given by mx of t is equal to summation x equal to 0 to n e power tx p of x, where p of x is a probability mass function, where p of x is equal to, from the binomial distribution, ncx p power x q to the power n minus x. Summation x equal to 0 to n e power tx, p of x is equal to ncx p power x q to the power n minus x. So next we are going to collect e power tx into p power x. So e power tx can be written as e power t whole to the power x into p power x. So this is, we can collect this two term p e power t whole to the power x into ncx q to the power n minus x. That is equal to summation x equal to 0 to n ncx p e power t whole to the power x into q to the power n minus x. So and then we can substitute x equal to 0 plus x equal to 1 plus x equal to 2 plus and so on up to n. So first x equal to 0, nc 0, that is equal to 1, p e power t whole to the power 0, that is equal to the 1, and q to the power n minus x equal to 0, that is only q power n, plus nc1 x equal to 1, q to the power n minus 1, p e power t whole to the power 1, plus nc2 q to the power n minus 2 into p e power t whole to the power 2 plus and so on. So already we know the binomial expansion. We can write q plus p e power t whole to the power n. This is moment genetic function of the binomial distribution. Next, we are going to find out mean and variance of binomial distribution. So that is, from the moment genetic function, we are going to differentiate with respect to t at t equal to 0. We can get mean, that is e of x. So we know that is mx of t is equal to q plus p e power t whole to the power n, be the moment genetic function. Then mean is equal to e of x, that is equal to mx dash of at t equal to 0. First time differentiate with respect to t at t equal to 0, we can get the mean. So that is mx of t is equal to q plus p e power t whole to the power n. So differentiate with respect to t. So first one mx dash of t, that is n power n into q plus p e power t whole to the power n minus 1 into differentiation of q plus p e power t. Differentiation of q, that is constant 0, plus p be the constant into e power t. Differentiation of e power t, that is equal to e power t. So next we can simplify, that is n into q plus p e power t whole to the power n minus 1 into p e power t. So at t equal to 0, that is n into q plus p e power 0, that is equal to 1 to the power n minus 1, then p into e power 0, that is equal to 1. So next we can write n into q plus p whole to the power n minus 1 into p. So q plus p is equal to 1, already we know. So therefore np, that is mean of the binomial distribution, that is equal to np. That is what? E of x or mx dash of at t equal to 0. So that is equal to np. So we can take another one of the equation. Next we are going to find out variance, that is, we know that variance is equal to e of x square minus e of x the whole square. That is, e of x square can be written as mx double dash of t equal to 0. So second time differential with respect to t at t equal to 0, we can get e of x square. So from the equation 1, mx dash of t is equal to np into q plus p e power t whole to the power n minus 1 into e power t. So next we are going to differentiate with respect to t second time. That is, np be the constant we can take as it is into first one, that is uv. So product of two function, that is first one u we can take as it is and v differentiate with respect to t, plus second term we can take as it is and the first term differentiate with respect to t. That's all. So what is np into q plus p e power t whole to the power n minus 1 as it is, differentiation of e power t plus second term e power t as it is and differentiation of this first term, that is power n minus 1 into q plus p e power t whole to the power n minus 1 minus 1, that is n minus 2, into differentiation of this term q plus, that is a differentiation of q, that is equal to 0, then p into e power t, differentiation of e power t. That's all. Next we can substitute at t equal to 0 immediately, that is q plus p e power 0, then e power 0 plus e power 0 n minus 1 q plus p e power 0 to the power n minus 1 into p into e power 0. E power 0 is equal to 1. So what is remaining term? np into q plus p plus n minus 1 into q plus p to the power n minus 2 into p. So q plus p is equal to 1 already we know. So we are going to substitute q plus p 1, that is 1 to the power n minus 2, that is equal to 1. So that is np into 1 plus n minus 1 into p. So next we can multiply, that is np minus p. So that is np into 1 plus np minus p. So multiply with this np, that is equal to np into 1 np plus n square p square minus np square. Next, so this np minus np square we can collect separately, then we can take outside this np, that is np into here 1 minus p plus n square p square as it is. So 1 minus p is equal to q already we know. So therefore np into q plus n square p square. This is e of x square, that is mx double dash of at t equal to 0, that is equal to npq plus n square p square. So variance of x is equal to e of x square minus e of x the whole square. E of x square npq plus n square p square minus e of x the whole square. E of x is equal to mean, that is np. So np the whole square, that is equal to n square p square. So plus n square p square minus n square p square will be cancelled, remaining npq. Therefore variance of x, that is equal to npq. Therefore the binomial distribution mean np and variance npq. Q plus p e power t whole to the power n be the moment generating function of the binomial distribution. Thanks for watching. Keep learning and growing.